Hi everyone, my name is Diana Solano-Oropeza. I'm a third-year PhD student at Cornell studying astronomy. With all the data that we have, it is a challenge to identify targets to prioritize in the search for technosignatures. I present the way to do just that by looking at potential targets in the Earth transit zone. The Earth transit zone is a narrow region in space with a special property. Stars passing through this region are able to witness an Earth-Sun transit from their point of view. This means that any civilizations that happen to call these stars home may be able to detect Earth as a habitable planet using the same methods that we use to characterize exoplanets today. A few years ago, my advisors, Lisa Kaltenegger and Jackie Faherty, took data from the Gaia satellite concerning stars in our solar neighborhood and calculated the positions of these stars throughout the past and future 5,000 years. They found that thousands upon thousands of stars entered the ETZ throughout this time period, and among these stars were 7 exoplanet host stars, whose motion through the ETZ is plotted on this diagram. Since then, we've continued to find lots and lots more exoplanets, and thus this presents a new challenge. How do we update our catalog to reflect this new knowledge, as well as extend our timescale from the past and future 500,000 years? This is how I did it. First, I selected exoplanet host stars within 100 parsecs, which corresponds to the outer edges of our solar neighborhood from the NASA Exoplanet Archive. Then, I matched these stars to their respective entries in the Gaia data and assigned them their Gaia positions, tangential velocities, and radial velocities. At this point, I already diverged from prior work, as previously, Gaia radial velocity was not available, so only 2D stellar motions could be calculated. I proceeded to calculate the full 3D stellar motions over the past and future 500,000 years. Lastly, once all is said and done, I filtered for stars that enter the ETZ at any given point in time. This means we get 360 exoplanet host stars that are able to see us transit the Sun over the past and future 500,000 years. These stars are plotted in this color magnitude diagram. They are distinguished by the kinds of radial velocities, if any, as well as a RUI. RUI is a data quality marker established by Gaia. The smaller the RUI, the better. The best ones are outlined in white. Overall, over 500 exoplanets orbit these stars. Stunningly, roughly 87 habitable worlds are present among these planets. Now, the number 87 should be taken with some caveats. It turns out that when you calculate planets in the habitable zone, you'll get a different number depending on whether you use NASA Exoplanet Archive solar parameters or Gaia DR3 solar parameters. Regardless, we've taken the overall total of unique planets across each set and plotted them here in clusters according to their stellar type. The outer bounds correspond to incident fluxes that we think Mars and Venus may have had when they lost their surface liquid water, while the inner bound is based off estimates by atmospheric models. So you might ask, what does this mean for SETI? Where do we go next? Well, first, this means we can think about timing our targets. And it also invites questions of thinking about Earth as an exoplanet through time. Second, our framework can be used to inform technosignature and biosignature searches. Lastly, we plan to expand our knowledge of the ETZ by running our simulations for longer timescales across further distances stretching beyond the solar neighborhood. This will require incorporation of galactic potential effects on stellar motion, which we currently do not account for. Lastly, once the Gaia satellite releases its final parameter set at the end of this year, we will update this catalog with those parameters and cross-compare for any changes. If you like this paper, go ahead and check out my poster PDF. Thank you.